Last lesson, we looked at measures of central tendency for one variable data sets. In other words, where the middle of a data set is, and that's really useful information. What's also going to be useful to us, though, is how spread out the data is. When you put those two things together, you got a pretty good visual of how data is behaving. You know where the middle is, and you know whether it's tightly grouped together or spread out. That's our measure of spread. There's various ways we can measure how spread out things are, and we're going to look at a few of them in this lesson. So, measure of spread is the measure of how widely data vary around their central location. So one thing is that we can look at is percentiles. Percentiles are often used in science and medical professions. The example that always comes to me as a parent is when a new baby is born, you take your baby to the doctor for its checkup, and they'll tell you that your baby is in, say, the 38th percentile for weight and the 75th percentile for height or length. And that just gives you an idea of where it compares to other babies. So 38th percentile for weight means that 38% of babies that they have data for would be lighter than your baby, and the rest, which I guess would be, can't think today, 62% would be higher, all right? And so percentile gives you the number of, or the amount of pieces of data as a percent that are less than the one you're looking at. And we've already looked at the median. Just to tie that into what we've already looked at, the median is called the 50th percentile. So there's a couple things we can look at to do with percentiles. Two calculations. One is the percentile rank, which just gives you the actual which piece of data you would be in a particular percentile, and then there's the percentile calculation itself. So R for rank equals P for percentile divided by the population size, which is n. All right, and so we use n plus 1 often. As we saw for median, when we were trying to get the middle piece of data, then we would do n plus 1 and divide that by 2. When we're doing percentiles, we do n plus 1 and we divide it by 100. Again, I'm sort of talking about what the variables stand for right now. It'll make more sense once I do an example. The other formula is the actual percentile formula, and that's P again for percentile. And then we need to know how many pieces of data are less than it, because again, that's what percentile measures, how much data is lower than something. So L stands for the number of data points that are lower than what you're looking at. And E is going to stand for the number of data points that are equal to it. Because sometimes a particular number could, or a particular piece of data you're looking at could have other ones that are equal to it. Again, if that's not making perfect sense to you right now, don't worry. We'll look at some examples. In fact, there's some more definitions here, but maybe I'm just trying to think if I want to jump ahead and do an example of that right now. Yeah, I think I will. So I'm going to jump down to example 1 and look at that. So the list shows the marks for 25 students on a recent test out of 40. So the test was out of 40. 25 students took the test, and there are their marks all laid out, 31, 28, 28, 30, etc. So they're not in order. The first question asks us to look at the 80th percentile. Percentiles are like medians, as I already mentioned. They only make sense if we put things in order. So that was the first thing that I had to do, and in order to save time, I did that before I started the recording. So I took all these numbers and I wrote them out from lowest of 15 to a highest of 40. Right. Then it makes it easy to actually do it. So calculate the 80th percentile. So I want to know which number in this list is the 80th percentile. In other words, I want to find the number that has 80% of the data below it and therefore 20% of the data above it. So that would be percentile rank. So R equals P over 100 times n plus 1. Again, n is the number of pieces of data. So that would be n there, 25. So it's simply just 80th percentile, that would be our p-value. So we have everything we need. So it would be 80 over 100, or 0.8 in other words, times 25 plus 1. Again, it's just like finding the median, except instead of finding the middle one, I'm finding the piece of data that is 4/5 of the way along in this case, 80%. That works out to be 20.8. What does that mean? Well, that means that I'm going to round it up to the next one. So I'm going to round that up. I'm going to say that the 21st piece of data is the 80th percentile. Okay, great. If I were to go through and count, so I'm just looking at my list of numbers in the ordered one that I wrote out myself, if I try to find the 21st piece of data, well, that would be 36. I'm just looking at it here. That would be this one I just highlighted in yellow. I just did a quick count. The number 36 is the 21st number in that list. That makes it the 80th percentile. 80% of the data is less than 36. So my answer is 36. 36 is the 80th percentile. Percentile. What percentile is a mark of 25? Okay, so this time they're asking what percentile is something. So I need to use the other formula, P equals L plus 0.5e over n. And again, we know what n is. N is 25. Now L is remember, the number of pieces of data that are less than what we're looking for. So we're going to find 25 on the list. Let's do that in blue here. So 25 on the list is here. Well, actually, there's 3 of them, so I'll highlight all of them. It doesn't really matter for that. And L is the number of pieces of data that are lower than 25. 1, 2, 3, 4, 5, 6, 7. Right? There's 7 numbers to the left of those 25s. So 7 is L. And how many numbers are equal to 25? There's 3 that are equal to 25. You can see that I've highlighted 3 numbers. So 0.5 times 3. When I work that out, that gives me 0.34. or 34%. So 25 is in the 34th percentile. What percentile is a mark of 40? Well, that's the highest mark, right? But it doesn't mean it's in the 100th percentile because we still have to use the formula. So in the 100th percentile, to find out what the percentile is, we'll go back to this formula. As I said, 40 is the highest mark. If we take a look at the list, we know there's 25 numbers there, so there's going to be 24 that are lower than 40. And there only is one 40, so let's say there's one equal to 40, and we'll divide that by n, which is 25, which gives me 0.98, or 98%. So 40 is in the 98th percentile. So there's a couple of examples on how we can use percentiles. We can either calculate what the percentile is, or we can calculate what where a particular number would be to be a particular percentile. Okay, so now I need to go back up to the top to look at some of the other definitions. To better understand the variability of a data set, you can use a variety of measures of spread. You can use what's called a box and whisker plot. That's a good one to visualize, to visually demonstrate the spread of data along a number line. So this one gives you a good idea just at a glance of what something looks like. So we'll do one of those, but before we do, just a description of what it means. What it is, it's going to be a line, and then there's going to be a box in the middle of the line. It's going to look like this. Let's do a pen. It's going to look something like this. Okay, that's going to be the general idea of it. So the line, the horizontal line down the middle, will give us our, it will be on a scale. The lowest, the left of that line will be the lowest number there is, the right will be the highest. And the box in the middle is going to give us some measures of the middle of the data. All right, so we're going to have to calculate all those measures, but we'll get a good idea of what's going on. If you notice, what it does is it divides it up into quarters. There's actually 4 quarters there divided up horizontally. So we got Q1. In other words, this is our first quarter. I don't know if I want to call that Q1 actually, but we got 1/4 of the data here will be represented by this, and 1/4 would be of the data to be represented by this part, and 1/4 here. And obviously when I add up these 4 quarters, that's going to add up to 100% of the data, all of the data. So that's the way we're going to look at it. And then these lines are going to give us actual numbers dividing it up. So these quarters are actually called quartiles. Okay, so these zones are called quartiles. So the one on the far left would be the first quartile, then we have the second quartile, the third quartile, fourth quartile. The first quartile is the middle number between the smallest number and the median. So in other words, Q1 is the dividing line, or the point, dividing point, between this smallest number and the median. The median is going to be right there in the middle. So the first quartile is going to be right in the middle between those two. It's going to be the middle number between those two. And then we have the second quartile, which is also known as the median, and that's going to be in the right here. So that's median, but we could call that Q2 as well. Then we've got Q3, which is going to be halfway between the middle and the highest number. So that's what Q3 would be. All right, so that's how it divides it up. And so Q3, if I was to think of it as a percentile, Q3 is 3/4 of the way along, which would be 75%. Q1, thought of as a percentile, is 1/4 of the way along, that would be 25%. So we'll do a box and whisker plot in a moment. In fact, let's do it now. We've already got this data. We'll carry on with example 1. We got this data set here, and we can identify some different information to go along with it. So in order to do the box and whisker plot, I need to know what the lowest piece of information is, I need to know what the highest is, I need to know Q1, the median, and Q3. And so lowest and highest are easy. That was 15, and the highest was 40. Just going back to look at our list. All right, here's the lowest here. There's the 15. Here's our highest. That was 40, right, on this list. So I can even begin by just making a scale up on this grid as long as it has enough space to get 15 to 40 on there, I'm good. So maybe I'd start with, I don't know, maybe 10 down here. And I'll go up by, say, if I have every 2 grid lines go up by 5, then I think I can make it fit. Let's give it a shot. There we go. So from 15 to 40, I've got enough room horizontally. So what I want to do is just pick a spot somewhere in the middle of this grid where I'm going to draw my line. So maybe this middle line here, I'll put a dot here at 15. I'll put another dot here at 40. Those are my 2 extreme values, my lowest and my highest. I'll connect those 2 with a line. Okay, so we saw up above that we have to have a line. Now there's going to be a box in the middle. That's where Q1, Q3, and the median are going to come from. So calculating the median, we saw this last lesson. The easiest way to do that is to do n plus 1 over 2. In other words, number of pieces of data, which was 25 in this course, in this case, 25 marks. So n plus 1, 25 plus 1, 26, divided by 2 equals the 13th piece of data. If I go back to this list and find the 13th piece of data, then it would be 2, 4, 6, 8, 10, 12, 13. I believe, I just lost my spot there. I believe it's this 28 here. It's definitely 28. 2, 4, 6, 8, 10, 12. No, it's the one slightly over. No, I had it right the first time. My bad. Anyway, so it's that middle piece of number, that middle piece of data. It's going to have 12 numbers to the left of it, 12 numbers to the right of it. All right, so that's my median. I can mark that on here. So 28 on my grid would go just about here. If 20, I guess this line just to the left of it would be 27.5, so 28 would be about here. That's my median. If I want to calculate Q1, I'm going to do it the exact same way, really. Q1 can be calculated by doing, I want to find the place of the particular number I'm looking for. So instead of doing n plus 1 divided by 2, I can do n plus 1 divided by 4. Because it's 1/4 of the way through. Remember, n plus 1 was 25, so I would do 26 divided by 4, which equals 6.5. So in other words, I want it between the 6th and the 7th place. Okay, so Q1, the 6th place, again going back to my list, 2, 4, 6. The 6th place would be 23, the 7th place would be 24. So it'd be 23 plus 24 divided by 2. If it's in between, it's always just the average of the 2 numbers. So just add them together, divide by 2. That's always going to be the case. So halfway between 23 and 24. So Q1 is going to be 23.5. I'll mark that on my graph. Again, I can only sort of estimate. 22.5 is this dotted line, so 23.5 would be about here. And then let's do the same thing for Q3. The place for that one is going to be n plus, well, really it's going to be n plus 1 divided by 4 times 3, or I could do 3/4 of n times n plus 1. In other words, just to find my way 3/4 of the way through it. So 3/4 times 25 plus 1 is 26. Again, would be 19.5. So I want between the 19th and the 20th place. So the 19th place was 32 from looking at my list. The 20th place was 34. And so Q3 is going to equal 33. Okay, put that on my graph here. And these are the ones I use to draw my box out of. Let's see if I've got a shape I can make work for this. Again, there's no particular size. I'm going to start here for drawing my box. Oops, no, I'm not going to start there. I need to make it match up with this point. I'm going to start here for drawing my box. I'm going to make it go through that point on the left. I'm just going to make it go, as far as up and down goes, I'm going to make it go high enough that I can see it. I'm going to make the right-hand part go through this line. So in other words, let's draw a box that goes through those two dots I already made. Those are Q1 and Q3, so the box goes around Q1 and Q3. And as for the median, I would draw one more line here. And there's my box and whisker plot. So remember what these different values were. So the lowest mark here was 15. The Q1, I'm just going to write it above it, was 23.5. The median was 28. Q3 was 33. And the highest was 40. I don't need to write those numbers on there necessarily. I should be able to read them from the scale, but it's good to just point this out to you guys. So that's how you do a box and whisker plot. Jumping back up to the top yet again. We also have the range. The range is the difference between the highest and the lowest points. It's a crude calculation. In other words, it's not very accurate, but it gives us a little bit of an idea of what the spread is. We have the interquartile range. That's the difference between the first and third quartiles. It represents the middle 50% of the data. And so we use IQR to stand for interquartile range. It's just Q3 minus Q1. So let's go back to our example again. This one doesn't ask for the interquartile range or the range, but I'm going to put them on here anyway. So the range for this one is equal to the highest, which was 40, minus 15. So the range was 25. So sometimes people, if I ask for the range, they'll say, well, it's 15 to 40. Well, yes, it is 15 to 40, but when we ask for the range, we want you to actually subtract them and give me a number. So I want you to subtract the lowest from the highest and tell me the range is 25. IQR, interquartile range, is Q3 minus Q1. So in this case, it was 33 minus 23.5, which is going to equal 9.5. What that's telling me is that 50% of the data falls in a range of 9.5 numbers. And we have one last thing to look at as far as formulas go. We can talk about outliers. So outliers can be calculated using the interquartile range if we have all this other information already calculated. We can get the lower outlier by doing Q1 minus 1.5 times IQR, and we can do the upper outliers, other end, if we do Q3 plus 1.5 times IQR. Again, these are numbers that are at the extremes, so we have to have we got the two extremes. We got the lower extreme and the upper extreme, so we have to have the slight variation on the formula for each one of these. Okay, let's look at example 2. The table lists the heights of 20 boys who signed up to try out for their grade 7-8 basketball team. Determine the median, the range, the first and third quartiles, and the interquartile range. Okay, so this one we got some cumulative data, again, grouped data. We don't need to get the mean in this case, so you don't have to worry about using that formula, but we do have to go back to getting that, the median with group data. So for that, we need the cumulative frequency, which is where I just add them together again, right? So the first one, I look at the frequency, it's 1. The second one, I do the 1 plus 3. So just a reminder, I did this before, but I take this number, and I add it to the 3 that's already here, and now it equals 4. And then to get the next one, I take this number and add it to the 4 that's in this row, and I just keep running my total higher by adding each time. So 8 plus 7 is 15, plus 3 is 18, 19, 19 plus 0 is still 19. And then we have add 1, and there's our 20. So those are our 20 players. We also need to know the midpoint, right? This is group data, so 155 to 160. We don't know what the height of the boy is who's in this group, so our best guess is the middle. It's 157.5. And it's going to be the middle for each interval. Okay, so this data will help us get our midpoint and so on. So our median. So median, we want to take 20 plus 1, so n plus 1 divided by 2, 10.5. So we want between the 10th and the 11th. Okay, 10th and 11th. Again, because we have an even number of pieces of data. If we have an even number of pieces of data, it's going to be halfway in between two that we already have. So, since it's group data, again, I don't want to list all the midpoints, I'll write out 20 different numbers. I just need to find which interval that falls in. Well, the 20th piece of data is going to fall, sorry, not the 20th, the 10th and the 11th pieces of data are going to fall in the interval from 170 to 175. All right, and the reason for that, again, is if I'm looking to find, if I was to imagine writing them all out, by the time I get to the interval 165 to 170, I've only got 8 boys. By the time I get to the end of the next interval, I've got 15 boys. So the 10th and 11th must have fallen between the end of the 165 to 170 interval and the 170 to 175 interval. So it's got to be this interval here. So since it's got to be in that interval, we take the midpoint of that interval as our median. 172.5. Okay, we want to have the range next. The range equals the highest minus the lowest. The highest was 192.5. The midpoint, that's all we have to go on. The lowest was 157.5. And so that would be a difference of 35 centimeters. We want to have the first quartile. So the first quartile, Q1, is equal to 1/4 n plus 1, or n plus 1 over 4 as I did it before. Remember, n was 20. So in fact, let's just replace that n with a 20. So 21 divided by 4 equals 5.25. Now, pay close attention to this part. 5.25 is just telling me that it's between the 5th and the 6th piece of data, but not closer to the 5th, as you might think, because it's 5.25. It just means halfway. So we just want it halfway between the 5th and the 6th piece of data. So in other words, don't get hung up on the 0.25 part. We're just going to take the halfway mark. So the 5th piece of data and the 6th piece of data, in this case we don't have to actually do much of a calculation because they're going to be the same since we're talking about intervals. That's going to fall in the interval between 165 to 170, so we would take the midpoint, which is 167.5. Doing the same thing for Q3. We're going to do 3/4 times 20 plus 1. That gives us the 15th, 15.75, so halfway between the 15th and the 16th. Again, I want to emphasize that halfway point. Don't let the 0.75 there throw you off. It's just in the middle between the 15th and the 16th. And the 15th and the 15th one comes at the end of the interval 170 to 175. And the 16th comes in the interval 175 to 180. So this is actually straddling two different intervals. So in this case, I do have to actually take that into consideration. So in other words, let's take a look at the table here. The 15th piece of data is going to be the last one here, whereas the 16th piece of data is going to fall in this range here before we get to the 18. So they're covering two different rows of the table. So now I'm going to have to average these two. So Q3 is going to equal the midpoint from the 15, our best guess for 15, 172.5, and our best guess for 16, 177.5, which works out to 175. So that would be our Q3 there. Our interquartile range, once we've got Q3 and Q1, is going to be the difference between them. 175 minus 167.5. Okay, if we want to create a box and whisker plot, now we've got all the information we need. I need to go from 157, or at least have room to go from 157 up to 192.5. So, let's see, if I go up by, if I start at 150 and go up by 5s, but I'll only label every second one. I got enough room there. So my lowest was 157.5. So again, I'll pick a line, I'll put it there. My highest was 192.5. Put that there. Connect those two dots. There's my whisker. As for the box, I need to know what Q1 was, 167.5, that would be here. Q3 was 175, that was here. And the median was 172.5. So these are all very close together, these ones. But that's just the way it works out. So it's not my choice, I just have to go with what I've got. So I'll start with a box over here on the lowest one. I'll go over to the highest one, which was Q3. I'll add my line in for the median, which was about here. And there's my box and whisker plot. So again, if you look at this one, you get an idea of what's going on. You can see that 3/4 of the data, remember this divides, these different sections divide the data into quarters. We've got the lowest quarter, which is down here. Then we've got the middle half of the data, which is in this box. Then we've got the upper quarter, which is up here. That upper quarter is spread out about the same amount as the lower 3/4 is. So we get this idea of the spread from the box and whisker plot. I'm not going to label the specific numbers on there. Describe the data in each zone of the plot. Identify any outliers if they exist. Well, I just basically described the data in each zone. Then I guess I can write it out quickly, though. Upper quarter is most spread out. Middle half, the IQR, is tightly grouped. And I think that pretty much covers what I want to say about it. The last thing is to see if there's any outliers. So remember that we had to do two different things for outliers, just to go back all the way up here. The one I did in yellow, the one I highlighted in green. So to find if there's any outliers from the lower end, I would do Q1 minus 1.5 times the IQR. So let's just do that for starters. So the formula was Q1 minus 1.5 times the IQR. So what was Q1 again? It was 167.5. And the IQR was 7.5. When I work that out, I get 156.25. What I'm looking for, are there any raw data numbers that are less than 156.25? So I'll go back to my table. My lowest number here was 157.5. So in other words, that is not lower than that number I just calculated. So I'll just write it like this. It's not less than, or it is less than, sorry. It is less than 157.5, my lowest data set. So there's no outlier, at least on the lower end anyway. Let's check the upper end, see if there's any outliers on that end. Remember, again, we might see some outliers on this end. We might expect to see some outliers on this end because of the fact that this upper end is so spread out. For that one, the formula was Q3 plus 1.5 times the IQR. And Q3 was 175. That works out to be 186.25. And we do have some numbers that are greater than that. We had 187.5 and we had 192.5. Having said that, we didn't have any students who fell into the 185 to 190 group, so we can't really say that was an outlier. But we do have that one boy who fell in the group between 190 to 195, right? He's the one who's that outlier who's giving us that extra long whisker on the right-hand side, so he would be an outlier because of his height. So that number there is going to give us our outlier. So once again, we have the one boy, 192.5 is an outlier because it is greater than 186.25.